Okay, hello and welcome to Calc Lesson number 27. We are looking at our day 5 of 2.6 related rates, and today we are going to be looking at shadows. Okay, let's get started with a warm-up. This says a person 5 feet 3 inches tall, which is 5.25 feet, casts a 6-foot shadow. At the same time of day, a lamppost casts an 18-foot shadow. What is the height of the lamppost? So what we want to do is find this value of x. In order to do that, we need to recall similar triangles. So here, because we have two similar triangles, we can go ahead and set up a proportion to solve for x. So we can set up a ratio of the height of the person, 5.25 feet, over the length of his shadow, which is 6 feet, and set that equal to the height of our lamppost, which is x, over the length of the shadow, which is 18. From here, we can cross multiply, so we have 6x equals 5.25 times 18. So 6x equals 94.5. So we're left with x equals, dividing by 6 on both sides, 15.75. So the height of our lamppost would be 15.75 feet. Just a quick warm-up, as similar triangles are going to be really important as we move through this lesson. Okay, so before we really get started with the calculus, I just want to introduce you to the types of pictures and visuals that we're going to be seeing in this section. So if you look at the first picture on the left, we have a height of a lamppost, we have the height of a person, we have the distance that the person has walked, but what we don't have filled in is a variable here for the length of the person's shadow. So the way we would set up these similar triangles is we would first pick out this triangle of our person and his shadow, and we would set up the proportion of 6 feet over our unknown x, and we would set that equal to, and then looking at our larger triangle, we want to look at the whole entire triangle, so we want to put our height 15 over the bottom of our triangle. We're actually going to list as 40 plus x. So making sure to account for both pieces of the bottom there. Looking over at our second example, here we have the height of the person and the height of the lamppost, but that's pretty much all of the information we have at this time. So here I'm actually going to fill in two variables. I'm going to fill in an x for this piece here and a y for the shadow. So now when I go to set up my proportion, looking at my smaller triangle first, I'm going to fill that in as 5.5 over y, and we can set that equal to our bigger triangle, which would be our height of 12 over that whole bottom is actually going to be x plus y. So just some quick practice in setting up our proportions before we actually get started with our calculus. Okay, and here we go. This says a light is being raised up a pole. So I'm going to get my picture going as we read this. A light is being raised up a pole. So here is my pole and my light. And it's being raised up. It says the light shines on a man who's 2 meters tall and 15 meters from the pole. So I have a man. And we know that he is 2 meters tall and he is 15 meters from the pole. And it's casting a shadow on the ground. So here is his shadow. At a certain moment, the light is 20 meters off the ground, rising at 3 meters per minute. How fast is the shadow shrinking at that moment? So I'm going to go ahead and set up some triangles here. So I see that I am going to create a triangle with the man and his shadow, just like I did in the introduction. And then I'm also going to have a larger triangle with my pole. Okay, I've got my similar triangles. Now I'm going to go ahead and label the missing pieces. So I'm going to label the shadow as x and the lamppost as y. So I'm just going to go ahead and list what is actually given to me in the problem. So they're telling me at a certain moment the light is 20 meters off the ground. So that's going to be the height of my light right now is labeled as y. So they're telling me y is 20 meters, and it's rising at 3 meters per minute. So that means this change in y, or dy dt, is equal to 3 meters per minute. And then they're asking me, how fast is the shadow shrinking at that moment? So they want me to find the change in my shadow, or the change in x. So dx dt, that is the question. So in order to do that, we're actually going to use similar triangles. So I'm just going to label what we're doing here. We're going to use similar triangles to set up a proportion. So just like we did before, I'm going to start with my man. He is 2 meters over his shadow is x, is equal to my entire triangle. That whole blue one would be y over, and then that whole base would be 15 plus x. And then from there, I want to cross multiply to create an equation. So I would get 2 times 15 plus x equals xy. So this gives me 30 plus 2y equals xy. I'm just going to cloud that for a minute so I don't lose it. Okay, from here I'm going to take that equation up, and I'm actually going to now differentiate that equation with respect to t, ECT. So we're going to take the equation that we have, 30 plus 2y equals xy, and we're going to differentiate it business as usual. So the derivative of 30 is just 0, plus the derivative of 2y is 2 dy dt. And then something exciting is that in order to differentiate xy, we have to use the product rule. So this is equal to the first times the derivative of the second. So x dy dt plus the second y times the derivative of the first dx dt. So we can leave that 0 there, or we can get rid of it because it doesn't really make a big difference. Okay, from here we're going to plug in what we know. So I'm leaving my 2. dy dt was 3 meters per minute. I'm just going to leave out my units for now. Now we have to plug in an x, and I don't know x yet. So on the side here, we need to find x when y equals 20. So we can set up that same proportion that we set up earlier. So we would have 2 over x equals 20 over 15 plus x. Cross multiply to solve, we get 20x equals 30 plus 2x. So 18x equals 30. So we're left with x equals 30 over 18, or 5 over 3. Okay, so taking that value and jumping back into where I was, I'm going to fill in my 5 over 3 dy dt, which was 3, plus y is 20. And then what we are actually looking for is that dx dt. From here, we can go ahead and simplify. So we get 6 equals, this becomes 5. Hold the phone. Okay, total false alarm. Don't be mad, but this is wrong because really, back it up, I totally messed up. And when I distributed my 2 in my head, it should have been 30 plus 2x, which makes this 30 plus 2x, which makes this a 2 dx dt. So this becomes 2 dx dt. So if you need your teacher to pause that and go back through, I am so sorry. Totally just like moving too fast. That should be an x. Okay. Unpause, and here we go. So now when we plug in, we have 2, and we don't know what dx dt is, so we're going to leave that. Equals 5 plus 20 dx dt. Now we can go ahead and move all of our dx dt's to one side, so we get negative 18 dx dt equals 5, and then dividing by negative 18 on both sides, we are left with dx dt equals negative 5 over 18, and now dx dt is the rate of change of the shadow, so that shadow is changing at meters per minute. Makes sense that it's negative because our shadow is shrinking. Again, I apologize about the total mix-up with the x and the y. Yeah. All right, here we go. Number 2, being really careful with our variables. It says a lamppost is 20 meters high. So we have our lamppost, nice and bright. And that one's not moving. This one is just 20 meters high. A man of height 2 meters passes underneath the lamppost and then continues walking at 3 meters per second. So here is this guy. And he is 2 meters as his height, not drawn to scale. And he is walking, and then there's actually 2 questions here. It says at what rate is the length of the shadow increasing, and then how fast is the tip of the shadow moving. So for right now, let's just cover this at what rate is the length of the shadow increasing, and then we will totally come back and handle how fast is the tip of the shadow moving. So let's go ahead and identify our 2 triangles. Whoops. We have this man, and I'm sure he's making a shadow, and he is one triangle. And then we have our lamp post as triangle number 2. Okay, so in this case, we know the height of the lamppost and we know the height of the man, but that is about it. So I'm going to label this first piece here as X, and then this shadow piece as Y. And it says that the man is walking at 3 meters per second. So what they're telling us, what is given, is that as he continues to move, what's actually changing is that x value. So dx dt, the distance between him and the lamp, is equal to 3 meters per second. And at this time, I think that that's pretty much all we know. Okay, here we go. Let's look. We want to know at what rate is the length of the shadow increasing. So we want to know how the shadow is changing. So they're asking us to find dy dt. So to do that, just like we did in the last problem, we're going to set up similar triangles. Starting with the man, let's set up our 2 over y equals, and then our whole triangle here would be the height is 20 over that whole base, which is x plus y. Oops. From here, we're actually going to cross multiply. So we have 2 times x plus y equals 20y. And then distributing, we get 2x plus 2y equals 20y. Moving our y's all to one side, we get 2x equals 18y. Dividing by 2, we get x equals 9y, and I'm going to cloud that equation. Not so bad to work with. So now we can go ahead and actually differentiate. With respect to t. So starting with x equals 9y, we get dx dt equals 9 dy dt. So we are looking for dy dt, but we know that dx dt is equal to 3. And dividing by 9 on both sides, we get, running out of room here, dy dt, the rate that the length of the shadow is increasing is equal to 1/3 meters per second. Okay, and then there's actually a little bit more to this problem. So for the next part, it wants to know how fast is the tip of the shadow moving. So what we're really looking at is this very end part of the shadow and how fast is it moving out. So thinking about how that shadow is moving, it's actually being affected by two things. So the man is walking at what they gave us, 3 meters per second, and we know that his shadow is increasing at 1/3 meters per second. So in total, that tip of the shadow is moving at both of those rates. So it's 3 meters per second of the walking plus the 1/3 meters per second as that shadow grows. I'm going to write this 3 as 9/3 plus 1/3. So this shadow, the tip, the end of the shadow is actually moving at 10/3 meters per second. Okay, last problem of the day, but just a quick warning, it is going to take a bit of room, so I wouldn't try to squeeze it at the bottom. I would make sure it has, enough space. So here it says a ball is dropped from a height of 20 meters, 12 meters away from the top of a 20-meter lamppost. That is a lot of info. The ball's shadow caused by the light at the top of the lamppost is moving along the level ground. How fast is the shadow moving 1 second after the ball is released? So you guys know me, I can't visualize anything without a picture, so I have a lamppost. Nice and bright. And my lamppost is 20 meters. Okay, then it says a ball is dropped from a height of 20 meters but 12 meters over. So I'm going to imagine that I went 12 meters over and then I dropped a ball. I don't know where it is. Let's imagine it's there. And then we're looking at the ball's shadow. So we have to imagine the ball's shadow is like out here somewhere. So we're still thinking about those similar triangles. I still have, it's not a person anymore. Now it's just this ball that we're dropping. Creates a triangle, and then our lamp post, of course, creates a triangle. Okay, so we don't have a ton filled in here, right? We know the 20 meters, and we do actually know that we have 12 meters in between where the lamp post was and the ball, but then I'm going to fill in, we don't really know this x value where the shadow would be, or this y value, the height of the ball. So in this instance, we actually have an extra first step where we have to use the vertical motion model to actually find our, quote, given information. So it's given, but it's just a little bit hidden. So the first thing we want to do is look at the ball's position equation. And we want to start by finding y. Okay, so they're telling us that we have the vertical motion model h of t equals negative 4.9, so h of t, the height of the ball, is going to be y equals negative 4.9 t squared plus v initial, and our initial velocity, notice that our ball is just dropped. So remember, because we are dropped, our initial velocity is 0, so we can go with 0t, and then h sub 0 is our initial height, and our initial height was 20 meters. So we can write our equation y equals negative 4.9 t squared plus 20, and we are looking 1 second after the ball is released. So we are looking when t equals 1. So we have y equals negative 4.9 times 1 squared plus 20. So y equals negative 4.9, because 1 squared is just 1, plus 20. So we get y equals 15.1, and it looks like we are counting in meters. Okay, that is one piece of given information, but I also need to find whatever else I can. So I also want to find x, and that I can do using my similar triangles. To do that, I'm going to set up a proportion using the y value that they gave me. So this 15.1, or that I found, over x equals 20 over 12 plus x. Cross multiplying, we get 20x equals 15.1 times 12 plus x. So 20x equals 15.1 times 12 is just 181.2 plus 15.1x. I'm going to bring this up here for a second. Subtracting that 15.1x from 20x, we get 4.9x equals 181.2. Whoops. Dividing by 4.9 on both sides, we get x equals 36.98. Okay, so far I found y, we found x, and we can actually find one more thing. So we can also find All right, let's see what they're looking for. They want us to determine how fast is the shadow moving. So we want to find dx dt. So then using our given information, we can actually find dy dt. How do we do that? Well, we have an equation for y, negative 4.9 t squared plus 20. So to find dy dt, we can actually just differentiate that. So we know that y equals negative 4.9 t squared plus 20. So dy dt equals, now notice we have our t variables, so when we differentiate with respect to t here, we're not even using implicit differentiation. 2 times negative 4.9 gives us negative 9.8 t, and remember we care about when t equals 1, so dy dt is equal to negative 9.8. So there was some given information, it was just kind of hidden. So once we've done all of that, now we can actually think about finding dx dt, and I'm going to go ahead and switch over to the next screen. So we'll just copy over all of this exciting given information that we found. Okay, so I just copied over all of those values that we found, and now that we are set up with our given and what we want to find, we can go ahead and set up a proportion using our similar triangle. So I'm going to set this up as our small triangle y over x equals our larger triangle 20 over 12 plus x. Cross multiplying, we get 20x equals y times 12 plus x. So we get 20x equals 12y plus xy. Now we can go ahead and actually differentiate. So I'm going to bring that up top here and we can differentiate. So we have 20x equals 12y plus xy. Taking the derivative with respect to t, we get 20 dx dt equals 12 dy dt plus, now in order for us to differentiate xy, we have to use the product rule. So to take the product rule, we take the first x times the derivative of the second dy dt plus the second y times the derivative of the first dx dt. Now I'm going to take my dx dt terms and move them both over to the left-hand side here. So I have 20 dx dt minus y dx dt, and that's equal to my dy dt terms that were left, 12 dy dt plus x dy dt. Now we could plug in from here. I'm actually just going to go ahead and factor out my dx dt and dy dt to make it a little simpler for myself. So if I pull dx dt out front, I get 20 minus y equals dy dt times 12 plus x, and now I can go ahead and plug in for whatever I know. So dx dt is what I'm looking for. So I have 20 minus my y value was 15.1 equals dy dt is negative 9.8 times 12 plus, we got x as 36.98. Simplifying wherever I can, I get dx dt times 20 minus 15.1 gives me 4.9 equals negative 9.8 times the quantity 12 plus 36.98 gives me negative 480.004, and dividing both sides by 4.9, I should get dx dt equals negative 97.96, and I need a unit, and this is how fast the shadow is moving, so our shadow would be moving at meters per second. So just take a second, make sure you followed all of those steps, all of those dx dt's and dy dt's. If you have any questions, you can ask your teacher just to pause it and to go over any part of it. Okay, really great job with those. I know that those were kind of challenging. At this point, you can go ahead and complete homework number 27 in your related rates homework packet. As always, if you have a question, please feel free to reach out to your teacher.